AP Cram, Calculus AB, Free Response Exam Review. Question 1. Definite integral. Water flow through a pipe. The rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t is equivalent to 20 multiplied by the sine of t squared over 35 cubic feet per hour. Okay, so cubic feet per hour is the unit of measurement of rainwater flow into the drain pipe. T, so the variable t, is measured in hours, where t is greater than or equal to 0 and less than or equivalent to 8. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by d of t is equivalent to negative 0.4 t cubed plus 0.4 t squared plus 0.96 t cubic feet per hour, remembering that t is measured in hours. Okay, so t is a unit of time. Also, for t is greater than or equal to 0 hours or less than or equal to 8 hours. And also, there are 30 cubic feet of water in the pipe at time t equals 0. Okay? So the first question I'm going to pose to you is, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval for t is either greater than or equal to 0 or less than or equal to 8. So they're asking during this entire time frame how many water is flowing into the pipe. Okay, well, how much water has flowed through the pipe. And just for more clarity, let's draw out what this might look like. So this is just going to be a really rudimentary sketch. So here goes the beginning of your pipe. There goes the length. And here goes the end. Pretend like this is water flowing in. And here goes some water flowing out. So what one needs to do to solve this riddle is to set up a definite integral. So anytime you're given a rate, okay, the rate we're given here is cubic feet of water per hour, but then you're asked for the total volume or the total matter or mass of the thing that you're given the rate for, and you're given a time interval. These are basically code words for setting up a definite integral. All right, so here's our integrand. The integrand is the equation that we're going to integrate. It's going to be r of t equals 20 times the sine of t squared over 35 cubic feet per hour. And we're given our limits of integration, which are 0 hours and 8 hours, okay? So we want to know between 0 and 8 hours how much water flowed through the pipe, okay? And again, these are code words for setting up a definite integral, because what the definite integral is going to do essentially is get rid of the dimension per hour, which changes this quantity from a rate into a mass or volume, okay? So we need to take the definite integral between our limits of integration between 0 hours and 8 hours. So we're doing the definite integral of r of t dt, and the reason why we write dt is because we're integrating with respect to time, which is t or hours, and whatever you're integrating with respect to, that's the dimension that you're going to get rid of. So we're getting rid of the t or the per hour. This might seem a little foreign to many of you. I know for most of you brainiacs, it's like a piece of cake. So that's what integration means in practical terms. You're kind of scaling back, going backwards, and getting rid of a dimension, okay? So when we plug in our integral, we get 20 the sine of t squared over 35, that's r of t, dt, and it's going to equal approximately 76.5704. And I know you're probably wondering, like, whoa, what the heck? How did you come up with that? Well, the trick is to figure out the integral and then plug it into your calculator. This is not a time to express that you understand theory, because in reality, this can't be solved by trigonometric identities or integration by parts. This is a special integral. So although you might recognize that it is a special type of integral, we don't need to know that on the AP exam, or we don't even need to know that on your in-class exam if you're an undergrad college student using this video for undergrad review, unless your teacher requires it. What it would really look like if we tried to solve it is 20, the sine of t squared over 35 dt, is equivalent to 10 times the square root of 70, the square root of 70 times pi s, and this s is something special. It's the Fresnel integral. I'll write it out for you. Excuse the time lag in my writing. Fresnel. Okay. You know, like if you want to be a brainiac, go ahead and figure out what the Fresnel integral is. But in reality, when you get into the real world and you get to a job, they're going to need you to solve a problem and not necessarily demonstrate your theoretical knowledge. So in learning these technical subjects like calculus, physics, chemistry, it's better, although this is going to seem counterintuitive, to learn the techniques first and then learn the theory second. Because when you do get paid, you're being paid to solve an issue or do a task, not necessarily to understand the theory. Although understanding the theory is sometimes essential, it kind of sort of shouldn't be your first priority. And I know a lot of people might argue with me on this mentally, but just trust me, okay? So times the Fresnel integral, 8 times the square root of 2 over 35 pi, and that's how we end up with our 76.5704. What is it going to be? Cubic feet, okay? I forgot to put in the units. So don't forget to put in the units for it to be a complete, concise answer. So you need to set up the integral again and plug it into your TI-83, your Casio, or whatever. And if you don't know how to do that, follow video 2 in this series, and I'll show you how to do that really quickly, how to set up a basic integral, okay? But let me just explain a little bit more about the Fresnel on the next flashcard for those of you who are more interested in this thing. Okay, so we said that this integral that we're analyzing between 0, and this is supposed to be a z, bear with the text, it's really faint. The integral that we're particularly trying to find is a Fresnel integral, and this italicized s, usually of z, where z is the upper limit, is what is the shorthand notation for the Fresnel integral. So that's going to always be of the form the sine of pi t squared over 2 dt, okay? And if we take a close look, our integral, the integral of r of t between 0 and 8, where 8 is our z, in this case, it is a Fresnel integral. It might not be so obvious. Here we have our sine, we have our sine, we have our t squared, and then the rest that we're left with that doesn't correspond is this pi over 2. But what we can do is factor out a pi over 2, and even factor out this 20, and then we would end up with our Fresnel integral. So making this like this is only a matter of algebraic manipulation, which some of you know how to do way better than I do. And we said again that that's equivalent to approximately 76.5704. But how do we arrive at this numerically? This is what we did, but the Fresnel integral is also equivalent to this. 1 over 2 pi, and between the lower limit of 0 and the upper limit of pi over 2z squared. So in our case, that would be pi times 8 squared over 2. The sine of t, okay, over t squared, over the square root of t. So here you can see that we basically took the square root of t and factored it out and so forth. All right, so this is the numeric solution for this. And that's how we ended up with 20, the sine of t squared over 35 dt being equivalent to 10 times 70 pi, because when we factor out and simplify, this turns into this. And again, this italicized s is basically saying that we're taking all of this and we're doing that to 8, which is our z, times the square root of 2 over 35 pi, okay? So basically what I'm trying to say is put this in your calculator. A lot of you want to know how to solve this and you're very thorough at it. That's really, really good. But for those of you who are not necessarily interested in this and you just want to know the technique, you just put this in your calculator. Or you can also put this into your calculator, all right, and make sure that you have it in degree mode and you make your z your upper limit of integration. And then you would get the answer, okay? And remember that the t would be like, you know, the time that you're dealing with, all right? Okay.